Okay, now we're going to examine very complex completing the square problems. This specific type of problem is indicative of something that you may see on the SAT. But the same simple rules of completing the square apply. Now, this specific problem is more complex because we have more variables than we're accustomed to. Typically, when we're dealing with a quadratic, we just have our x squareds and our x. But now we have an extra variable, which is a. All right, step one, we always isolate our x terms. I'm going to do that by subtracting 8a. I now have y minus 8a is equal to ax squared plus 2ax. All right, the number one rule of completing the square is we must have a 1 coefficient in front of the x squared. Right now, this a functions as a coefficient because a can represent any number. So what do? We simply factor the a out. Y minus 8a is equal to ax squared plus 2x. Now, I can complete the square with the remainder of the information that I have. I take my 2, or my b term, I divide it by 2. 2 divided by 2 is 1. 1 squared is simply 1. However, if I added 1 here, I really added 1a. Remember, we have to multiply whatever term we have here by what's outside the parentheses. Therefore, to keep the equation balanced, I have to add another a term to this side. Okay, at this point, I combine like terms on the left. I'm going to get y minus 7a is equal to ax plus 1 squared. Okay, I FOIL x plus 1 just to show you x squared plus x plus 1, x squared plus 2x plus 1. Boom, boom. That's where completing the square is coming into play. Now I need to get my y by itself, so I simply add 7a to each side. My final answer becomes y equals ax plus 1 squared plus 7a. Now we have completed the square for a very difficult problem that involves many variables.